I'm going to talk about fundamental training in RISC-V architectures and assembly program. And this may be so far removed from many of the attendees or people that will listen to the presentations later, but there is an audience out there that I think is potentially enormous of RISC-V designers, hardware designers, and software engineers and programmers at the assembly level and higher level languages that don't yet know about it. And what we're trying to do is scratch the surface at the low level and bring people on board. Lots of people have courses, but there's a bit of work to do, I think, to bring the community's courseware to work. So I'm just going to go and share my screen now and present. The work that we do is based in the university in the west of Ireland, Galway. We collaborate with some European partners. If you wish, everything that I'll show you is a live demo connected to real hardware. It's what we've been doing for over 10 years in NUI Galway, and it's robust. Now, today might be the day that that model breaks, but I hope it doesn't. If you want to download the presentation, it's at the bottom of each slide, but the links in each presentation will get you to do exactly what I'm doing as I'm doing it. We have 35 modules in the cloud in NUI Galway. We have the architecture supports distributed towers like this, and also locally connected FPGAs. These are Xilinx FPGAs on a pink Z1 or Z2 module. The system is built on vicilogic, which is an online learning, an online course builder, and an online prototyping system. So I want to just demonstrate first. We're finding when people come to our online course, they see courseware, but they want to play. So we know we have to improve things, but we've a plan, and hopefully you'll see what we have is already very good. But I'll start with a couple of demos. RISC-V introduction I'll go through very quickly because you are all aware of that, I imagine. What strategy are we applying? And maybe more demos. And what is the platform that we have built this courseware on? It's called vicilogic. Some more examples, and then experience of users to date within the university and others outside that have given feedback, the statistics that we have on the FPGAs that are used, and close with an invitation to use, and also maybe to engage with us on what you like and what you don't like or what you want, and maybe even work with us on courseware development. So this is the homepage of vicilogic. I'll let you scan that yourselves, and you'll see it during the demo. It's very visual, very interactive, but you have your left side of the page. It's videos, it's images, it's interactive images, and you'll see.
Fearghal,
yeah?
Your screen isn't showing. We've still got your front slide showing.
Oh, I'm sorry. I'm sorry. I apologize. Yeah, I see that now. I'm very sorry.
That's right.
Can you see it now?
We'd stop you before you got any further. Let's try again. That's it. That's it. That's much better.
That's great. I apologize. So if you wish, you can register on vicilogic.com. The presentation link is down at the bottom. And if you want to play with this, if you decide to do something else other than listen to me, by all means, feel free to join the links yourself. So I'll pass through the presentation overview. And this is the homepage. The left-hand and largest size is a playground for videos, for interactive engagement with remote hardware. Everything you see is remote hardware based in real time, and the signals that it has are going to be presented on the left-hand side. On the right-hand side, we have information, links, text, etc. And you move to a little bit more detail here. On the left-hand side, this is a picture of the instruction memory, 16 of the registers in the register bank, the program counter control unit. These are pictures that you are familiar with, similar to these pictures from the Hennessy and Patterson textbook. This is our arithmetic logical unit, but it's only a small portion of the overall architecture. And we've got LEDs and we've got hex boxes, etc., demonstrating signals. And over here, I've got the text. I'll show you a first demo. As I click on this, an FPGA will be configured with a RISC-V RV32i processor. This is one subset of the architecture, and the LEDs at the top have the instruction fields, the extended immediate, And then we have the arithmetic and logic unit, the A, the B, and the output ALU out, which is write back data into the register bank. The UI is reasonable, but it will get better, and we are embedding a RISC-V assembler. We have the instruction memory over here, and the current instruction is highlighted with the star. The blue and the yellow highlight the destination register and the source register 1, which applies for register immediate. This looks like a simulator. You may well ask, what's the big deal? What's the benefit in this? The idea of this online course is that it spans from chip design right through to the development of courseware, which show how each of the functions, components, and the whole RISC-V work together. Much of this can be done on a simulator, but you can't design and implement a HDL-based design and prototype it. So our system allows you to do all of those elements, and all of these tools complement each other. This isn't about saying that ours is the only way to do things. We have to have a little bit of lots of things, but this would be the architecture-based focus. That's what we have here. We have clock widgets, we've reset widgets, etc. as well. And you can see over on the right-hand side, what is installed here, or what is loaded here, is a 6-instruction program with exactly the same instruction. It's adding 5 to register 3, and the destination is register 3. I hope you can see the size of the text okay. And there's a little bit of information down the bottom. The program can be downloaded. This will all be embedded within a right-hand side assembler box over here. But as you continue through the course talks about the various elements. We can highlight widgets. Effectively, we can direct a user with a directed lesson or a guided lesson. And it introduces each block in turn, because everything we have in here is interactive. These little elements are widgets which are active. And it links to various places like the specifications for RISC-V. And eventually then, having introduced everything, and you can see some of these other widgets flashing on and off, it asks you to do something. It asks you to click on the clock. And as it does, the instruction executes and you can see things progressing. Much like a simulator, but it's working on real hardware. And it allows us to do lots of things in the future, like attach peripherals and to build some small program applications. We're not trying to do what the higher end tasks are. We're trying to just start at the low level gate and come up to a decent application. So it's waiting for the user now. It's asking me to keep clicking, and you'll see that after 6 instructions, it automatically moved. So it's I hope, giving you a sense that this is like a teacher. This is not putting teachers out of work. This is allowing you to focus on applications after someone follows this lesson on their own. Now it's asking me to assert signal reset. And again, it automatically moves and progresses because we can look at every signal as well as controlling every input and output. And I'll show you how that all happens. And again, it asks me to do the clock again. And once it does 6 instructions, it moves on, or at least it should. And it can't, because I'm asserting reset. I often make this mistake, and now the instructions work. And I can rerun, or I can go back to the introduction, which is the start of the course. So let me go back to where I was on the slide. Another demo, again, a register immediate demo. I've just configured an FPGA again. This time I have a longer program, and it's a series of register immediate instructions with shift left, etc. And here it's a sandbox, it's a playground, and you can see a lot of activity there. Some of them are displayed as LEDs formats as well as hex, so you can look at the bit manipulation of the registers as they're being handled. So that's a sense of the start of the course. Guided lessons, widgets, stars, etc. But we have plans to enhance all of these with banners and help our real estate and to install a back-end assembler. You can browse course contents up the top left, and you can ask a question up the top right. So if you go, for example, back to one of those demos and go into the course content, you can see, excuse me, that was a wrong link I have on my presentation. The course contents, it'll show you the various sections in the course. If you want to look for tools, then the section is here. If you want to look at each of the instructions in turn, register immediate, constant shift, LUI, they're all dealt with in the same way that I've just shown you there a moment ago. So back to the slides. I won't introduce what RISC-V is. I'll slip over this, I think, because I lost a little bit of time at the start. RISC-V is calling for courses. because the industry and the community need these courses. Where we fit in, it's hard to see where the low level fits into here, but I'm assuming it's under bare metal, because we're lower than anything else that I can see here at the moment. But there is an academic or an academia and training committee coordinated by RISC-V International. There are bi-weekly meetings. If anyone is interested in training or finding out about training and trying to help pull the various courses that exist at all levels into a place where people can connect with, to show what they have and also to find what's there, please join the committee. The strategy we use. So the Hennessy and Patterson pictures that we've seen before on the left-hand side resembles what we have on the right. We've tried to make them similar. And this is the most complicated the picture gets, but you can see the memory here, memory load, memory store, select paths. We've got some branching, and we've got register immediate and LUI, etc. instruction support too. Target audiences are professors, students, and hopefully people in industry who might not have looked at their underlying architecture and would like to see how things work, or how that immediate instruction work, or how memory store and load works. Self-paced, and you'll see that when I get to the end. So the course structure I showed you a moment ago has 6 or 7 sections in it, ranging from just introduction, the tools that are there, online simulator Venus we use, the assembly instruction by instruction, and the hardware supporting that, all integrated with the hardware. The prototyping element, the students that follow this course optionally can capture an entire HDL model for a RISC-V RV32 processor and prototype it. And we're working to extend custom instructions and things like that that will help us, add more interest to the course. Some games they've developed, and also then we have pipelining and hazard handling and detection, and some C, which we will develop some more. So I won't go through this structure. The times are all amounting to maybe 14, 15 hours of courses, and then there are labs as well. So it was most of a 1 semester course. How does it all work? We use remote hardware, PINC module, FPGA module. That's what's in this tower. We're also porting to Intel. That's almost available, but every one of these FPGAs has an ARM processor, an AXI interface, and programmable logic. And we connect the ARM across the web to the client. So as you click on a hyperlink here in the browser, the configuration occurs, and then we have a direct connection to the processor, or to the processor on the FPGA. So these are the arrangements that we can have, and we can support a locally connected PINC. We can have a centralized tower, or we have the architecture supports distributed tower. So you could actually share your resources if you're in a university with our resources here to help a larger community. So each of the FPGAs has an ARM and the programmable logic. A switch connects that to the vicilogic server. The server manages users, groups, and also manages projects that are uploaded, and then connects the controller with a user, so that once it's set up, the user literally has control of that FPGA for that session. How do we do it? We upload a project after we build the project, but we first of all take a user design, and all of the signals that are inside in blue here, we take to the outside, and we connect them to an internal control register, and then another register which is probing. So we see every signal in the system. We can selectively switch a few off if we're not interested in seeing them. And then all of that is built through the Vivado tools, and it generates the project. We upload the project to the server. We create what we call a view, the picture, and the widgets on it. And then we create a lesson step and put the step in a course. And we do the course steps as I just illustrated. Projects, etc., are all stored on the database. I'm going to give an illustration with a counter. So there's a video demo of this, but I'm actually going to do it live to show you that it will work. So this is a fundamental course, and I've gone to the wrong place. This is a fundamentals course with a counter. And again, I hope you're familiar with this, but if you're not, there's a fundamentals course that has a whole series of lessons on everything from flip-flops to muxes to counters. But this is a a 4-bit counter with 4 registers. It has a next state decode. It has signals like load and load dat and chip enable and up, etc. And it has an output count. And these are the typical things that digital designers would show. They would have truth tables, function tables, state machines, etc. And the course is built like this, and similar to what I've shown you before. So I can, for example, click on, I can't do anything at the moment. It's telling me you've got to wait and see. And take the next step. Now I have a timing diagram because I can see every signal. So we can bring things to life in various dimensions. Each of these pictures complements each other. And as you step through this, you saw that the count changed, and now it comes back again and it's decrementing the count. So this is a lesson. I'll go through it quite quickly. It then asks me a question, and it's called a knowledge check. And I've hidden a widget here, and it's saying, what is this signal widget? Currently, the count is 15. The load is deasserted. Chip enable is on. Up is 0. So it's counting down. And this value should go to 15, which is the value, 14 rather, which is the value E. It's currently at 15, which is F, XF. And I click on this, it says that's fine. So there's a knowledge check. Now it asks me to do something and helps me do this. And we'll apply this all to RISC-V shortly. Asks me to load the value 9 into the counter and then to toggle the clock. And there, lo and behold, we have a value 9 out here. And then it asks me to control signals in a particular way, and it gives me a sandbox control. Now, how did I do all that? If I click on the admin page behind, what we have is a project that was built. It's called Counter 4-bit. There's a series of signal assertions or deassertions that are all executed when I run the course. I can flash on and off signals. I can create a new text, which goes on the right-hand side. And these are all connected together. There's a loop function, which allows us to count up 8 times. There are delays in there to slow it down if we need to, because obviously it would run at full clock speed otherwise. I can change up and down here. There's a knowledge check, and it just asks me, what's the question? The question is on signal NS. So it says, what is it currently? And it automatically probes and compares your answer. And then it asks me to load, flashes, clock, load, and load dat. And all of that is, when it's built and saved and executed, it all runs. And that's the course. That's how we build the course. And anyone is able to go and prototype and build. And we haven't switched on this interface for people yet, but the plan is that that will become available. Then we create the design view. And I didn't show you the creation of the design view. It's one final piece, which I think is probably worth showing you. And if we go into here and go into the project itself, the project is simply a picture in the background, and it's a series of widgets. And we pull these widgets across, and I'm going to change this to an LED, and we're going to make it blue and apply it. So that's new, and that's new. And as I save this and rerun the lesson, the real hardware, click that twice, 3 times harder. The real hardware will execute, and the widgets will interact with the hardware, and we'll see all the various values. So you'll be able to see this because this is load data. Load data is no longer relevant. I picked a very bad example for a signal there a moment ago. I'm going to have to get to the place where I was loading, and it's here. So I can click on this now, and it's an LED, but it can still be changed by me, the input. So that's how we build courses. Some demos. This is a full demo of memory for load, store, and everything else. And again, here it walks you through. I won't go through the detail. It walks you through the structure of a store and a load. Actually, this is just a playground. It gives you a sandbox. And as I click on the clock, it's very much like a simulator, but it's talking to real hardware. And the pictures never get any more complicated than this. I'll move on. So here is a game where the students built before Christmas. This is one example of a little LED pattern. This is memory array, and as they click on a button, the paddle drops, and when the paddle doesn't drop in the right place, the game ends. So we need to add more bells and whistles to this, but they can do maze applications and a whole lot of other things as well. Each element and the internal operation of each element, say for example the ALU, can also be uploaded as a design, a unique design, to show how it works. So in this case, I'm going to select Shift Logical Left, which is the number 5, and I select the value of 5 into the Select ALU output, and this is the value A coming in, and I'm shifting it 8 bits to the left, and you can see that this is the same as this, but it's moving left. So I can change the number of bits that it's shifting. This is out of range, and so are those two because it's only 5 bits. But you can see that the unit level test is there to be looked at and understood as a building block for everything else. All these other examples are live and connect from the presentation to online demos. So one of the distinguishing features of this course is the group build an entire RISC-V processor, and in the future we'll be able to extend instructions, and we'll have an online assembler, etc. So that's just pictures from Xilinx tools. These are feedback from a captive audience of students in NUI Galway, but the feeling is quite positive. We've been building this system for quite a number of years, and this is sort of a rating of 1 to 10 on a course and various modules within the course. These are comments coming back from them as well. What do you like about it? Sandboxes, a combination of view and text, view on the left, text on the other. There are videos on there, signals on top, etc. Labs and exercises. So there's a lot of hands-on. And this slide shows us for all of the FPGAs that we have over a 3-week period. Each color is a unique FPGA and the number of times it's been configured. So we have a lot of analytics in the background. A couple of very busy days when assignments were due, and you can see that there's one user and their contribution and another user and their contribution, and the 45 students that did the course used this up. So we have about 115 or 120 configurations since February 18. To close, if you are, as you probably are, advanced in RISC-V, please share it with somebody who hasn't and has never seen RISC-V, because I hope that they can find it useful. We have an ask a question on every page, so they can ask a question and we help them. We have a range of courses. We will eventually do some RISC-V extensions to show how people would say, for example, bit handling. We can have a subsection in bit handling, dealing with how cache memory works, because I hope you can see we can bring hardware alive. So RISC-V links to our course at the moment. We also have a dual core RISC-V at the moment where we're starting to emulate peripherals so that we can build an assembly or C application, low level, it's not high level, that we can either connect outside to peripherals or that we can generate signals within the core in order to run a program and write a program for core 0. And we're going to put an assembler on there. We're going to be able in the course to auto load. We can click a button and it will auto load a program, and it will have a link to where that program is. So we will automate more and more the way that we can teach the fundamentals of assembly of hardware and hopefully some C. And we will extend each of these as well. So thanks for listening. I'd be delighted if you pass this on to someone. It's a case of just registering and coming on, and if they like it, they'll stay. If they don't, they won't. Thanks very much.
Thank you very much, Fearghal. Thank you for that presentation. Open for any questions. Please open up the microphone and ask anything, or type in the chat for any questions.
I have a question.
Yes, go away. Martin, yes. Martin,
yeah, Martin. Is your code open source, given the nature of the event tonight? I just had a look and I couldn't find a GitHub repo for your code.
It's not, Martin, because we haven't figured out how to, when to, or a community of people that are interested in trying to make this work. But I think, I mean, that would be really good. There are a few questions, and one is, how do we sustain this project? Because it has demanded a considerable effort over many years, and we still have to have this discussion. Part of me says we would love to share exactly what we have. Part of me says we should wait until we add most of the fundamental bells and whistles that we need. Part of me says we have our head in the sand if we don't have open source, but part of me says, how do we sustain this? Or how do we try to recoup some of the
so currently it's paid for?
No, currently it is free, and it will remain that way until it's something that a larger community of people are interested in. But resources are limited, and collaborations would certainly be beneficial. We just haven't got to the point yet where we said it's the back end is open source, but it is currently open. I would love to think that a subscription, if we're using real hardware, a subscription model would work. But I think that there is a model that will allow others to develop course material on this in whatever area of expertise that they have. So say you're an expert in cache controllers. It's a very straightforward exercise to find out how to use this, to get access to use this, and to develop a course.
So as someone who has been teaching for a while, however, in the software side, one thing I could think about monetizing is if you run it on FPGAs for real, then you pay for this. Otherwise, it's a very slow software emulation. And the other thing I can imagine is that you get paid for tutors, actual humans who can ask questions.
Correct. Good idea.
It's really hard actually to self-learn, but a lot of people, including myself, if they can just clone a GitHub repo and play with it a bit, they use that to inform themselves whether they should pay for such a course.
That makes perfect sense. What we currently have in this system is, if I go to this link, on the right-hand side up here, ask a question. On every single page, you can ask a question, and I will receive an email on that. So we have a facility to reach more than one tutor. This is quite a long way off getting to the point where we have a large community, but events like this evening really, I think, help us to be seen. And yeah, it's interesting. I think your feedback is constructive and positive and hopeful. We should have another conversation. I think it would be really good if we could connect.
Yeah, I'll send you an email offline. Thanks.
Thank you very much for the questions. Great.
Yes, I would put the comment that I think this is starting to get a crowded market, and I think Western Digital is involved with setting up a RISC-V university, and there are other emulators, not with FPGAs behind them, out there that are open source, and with an expectation of open source, that might become a barrier to you if you're not open source. And so I would strongly recommend that you look at the opportunities to open source and work out what your channels for generating revenue, because there is definitely value in human bodies. And if you see your software not just the thing you make money from, but the thing that drives revenue to your human bodies as teachers and consultants, that's quite an attractive business model. Because actually, I want to learn about RISC-V. My boss says it's the important thing. The ability to do a course, the course is free, and when I get stuck, I can pay and get access to someone. And you can do that on a micro level, or you can do it at all sorts of levels of granularity. But one thing I've found is that actually, we find this on all sorts of things, is companies will often pay for that sort of training stuff much more easily than they'll actually pay for software. So if you make the software free but charge for the consultancy, that's an easier sell. Selling training, selling coaching, and companies like it because it's tax efficient, because invariably it's tax deductible in a way that software isn't.
You're very good advisors. This is great. Yeah, good feedback.
Yeah.
Thank you very much.
So if I can chip in once again, I would like to emphasize what Jeremy said. I think a lot of professionals, they want to take a course and they may have a limited budget, like 3 days or 2 weeks. And in such a setting, you don't want to send an email and then get feedback a day later, but rather you want to get feedback in 5 minutes or 20, 30 seconds. And this rapid feedback is what is being paid for and what costs money and what I think you can charge for.
Yes, Yes, I agree. We very quickly put the Ask a Question facility on there, and we use it quite effectively. At the moment, the course literally ran for the semester last September till December, because we're all online, with 1 hour Q&A a week. And the rest of the time was interacting through the Ask a Question facility, and it was very effective. And our response time is quite high, or quite fast.
So another thing I can recommend is, I used to teach compilers, and I used MIPS until 2019, not because I hadn't heard of RISC-V before, but because there was no very easy for computer science students to use RISC-V emulator. And if I look at your stuff, it looks really, really nice, but I think there could be value in connecting this with a nice compiler with a compiler tutorial or something like that, that compiles to RISC-V, because then you suddenly had a course that straddles the hardware-software boundary in a way which I don't think any other course does.
We have started to introduce, Martin, the C programming, and I think you're right. I think if we do put the back-end tools on there, and they are connected to a course, like, everything is integrated. So you click on assemble, and it uploads at the same time.
Okay.
And it pulls the file from a central place related to the course. I think there is a scope to build something very powerful. The C compiler and an online compiler is something that really would be brilliant too. And I've found 1 or 2 of them that don't require any installation, and some of them are open source also. They are they've got great potential, I think, if we could integrate with our system like that. Yeah,
I agree. If I wasn't on a sabbatical, I would probably look into this, but right now I have other stuff to do. Thank you very much.
Great. Thank you very much for the feedback, both of you. Jeremy also, thank you.
Okay, well, thank you, Fearghal. Thank you to Nidal beforehand, and thank you to Ibrahim. And there's a comment there from Richard Miller as well, for you, Fearghal. Please do keep, we'll keep the channel open for a short while, but only a short while, and then we will call it an evening. I will stop recording now, though. So thank you for that, and do chat away for as long as you like, but we will end up shutting down the server sometime soon. Okay, so I look forward to seeing you in 3 months' time. Our provisional plan for the July meeting is SAIL and formal methods around RISC-V. If that's an area you'd like to hear, tell us about it. If it's that area you'd like to speak on, particularly tell us about it. We look forward to seeing you there. Thank you very much.